once the performer's location is known, all you have to do is actually light them. So just like I was mentioning in the overview section, a big goal of this project was to rely heavily on industry standards. Most theaters have a light board as a primary or maybe even the only point of control for the entire lighting system. And many theaters, not all, but many, have something called a moving light or movers. These are fixtures that are essentially just normal lighting fixtures attached to a 2 degree of freedom powered mechanical assembly. And so you can control the position of these lights. And on top of that, they often have other fun control surfaces like color gobos and pattern gobos, rotation, strobe, focus, all of this additional stuff on top of the position control. And so these are relatively expensive, but nowhere near the expense that an automated tracking system would cost. So up to this point, the only way to control these movers is using pre-programmed position instructions. And so I decided to utilize this existing technology that many theaters already have to make it do what I wanted. So the theater lighting infrastructure runs on a serial protocol called DMX 512. And protocol is really kind of a strong word for it. It's basically just 44 times a second, the light board spits out 512 channels of single byte data. And then the fixtures listen to that data. They know which channel they're on, and they respond to that. So these fixtures, the movers, typically have between 5 and 30 channels, depending on how many control surfaces they have and how precise that control is. And so by daisy chaining my device in between the light board and the movers, I can just overwrite the position control data to be whatever my system determines is the right control data, but leave the rest of the channels completely untouched. So the light board still has control over things like color and focus and all of that stuff that I mentioned earlier. And then on top of that, I can claim a single control channel for my device, which means that all of the configuration, the simple instructions like start and stop tracking, enter and exit transparency mode, all of that can still be controlled from the light board. So you still have a single point of control for everything, including my system. So the Raspberry Pi that I used receives and sends DMX using an NTEC DMX to USB converter, which was the most expensive part of the hardware setup for this prototype and could pretty easily be replaced with something that is made by hand, or maybe even a DMX Raspberry Pi hat that uses GPIO input and output, because the USB really is only serving to complicate the protocol.